Today we are going to continue with lecture 2 for chapter 3, which is the sequences and series. So we are going to focus on the first subtopic, which is in sequences and series, and then we continue with binomial expansion, which is 3.2, the subtopic 3.2. Okay, the learning outcome for today, at the end of the lesson, students should be able to, the first one is to find the nth term of geometric sequence and series formula, which is the Tn equal to A multiplied with R to the power of n minus 1, and to use the sum, which is Sn equal to A multiplied with 1 minus R to the power of n, all divided with 1 minus R, for R must not equal to 1. And then, on the second part, we are going to focus on the binomial expansion, which is the first one. We are going to find the expansion of a plus b to the power of n, where n is a positive integer. And then, to write the n factorial notation, and choose r as the binomial coefficient. Okay, so means that for part A is about the geometric sequences and series, and then the second part is about the binomial expansion. So geometric progression, so this is the continuation of the sequences and series, which is before we learn about the general and the arithmetic progression, and for today we are going to focus on geometric progressions. Okay, so what is geometric progressions? So geometric progression is a sequence of numbers which is any term can be obtained from the previous term by multiplying by a certain fixed number. We call it as common ratio. So what is the difference between geometry and arithmetic? The arithmetic, we have a common difference. So we are subtracting or adding with a certain fixed number. But for geometric progression, it is multiplying with a certain fixed number, where we call it as common ratio. Okay. A geometric progression is also known as geometric sequence and inaccurately as geometric series. The geometric sequence can be written as AR squared, AR cubed, and so on, and then it can be written generally as AR to the power of n minus 1. What is R? R is the common ratio, where R must not equal to 0 and 1. If it's 0, then everything will be 0 for the next values in the sequence. If it's R, so we will have the same values, which is A, in every value in the sequence. And then, what is A? A is the same as the arithmetic sequence, which is the first term. So we start the sequence with A. So, for example, for the first term, when A equal to n equal to 1. The first term means that the first term equal to T1. So by using the general formula AR to the power of n minus 1, which is 1 minus 1 equal to 0, we will have A. So R to the power of 0 is equal to 1. And then for the second term, it will be A to the power of R and then 2, because it's second term, T2 minus 1. That's why we will have AR only. 2 minus 1 is equal to 1. So the third term is AR squared. And then the fourth term is AR cubed, and so on. And then we will have the formula of general, which is general term, which is n term equal to AR to the power of n minus 1. Okay. The general term of geometric sequence is given by Tn is equal to AR to the power of n minus 1, and A is the first term, R is the common ratio. So you have to remember this formula to find the general term for each term in the geometric sequence. And then we can find the ratio if it's given a sequence by finding the ratio between the terms. So T2 with the previous term, which is T1, T3 by dividing the previous term, which is T2, and so on. And then on the general term, we have Tn divided with Tn minus 1. Let's do some example. Given the geometric sequence 8, 16, 32, 64, and so on, find the general term. So what is the general term? Tn equal to Ar to the power of n minus 1. And then T9. So to find Tn, we need to know what is our A, what is our R. So how to find our A? What is our A? Yes, our A is the first term T1, which is equal to 8. And then what is our common ratio? R. So we can use the second term and the first term, or the third term with the second term, or the fourth term with the third term. So for this one, we can use the second term divided with the first term, which is 16 divided by 8, which is equal to 2. And then we just need to substitute the value of A and R into the general formula. So Tn equal to Ar to the power of n minus 1. So A equal to 8 to R equal to 2 to the power of n minus 1. And then this 8 actually we can simplify to the base 2. So what is 8? 8 is 2 to the power of 3. So by using the rule of indices, everything can be simplified into 2 to the power of n plus 2. Why? This is equivalent to 2 to the power of 3, and then multiply 2 to the power of n minus 1 will be plus with n minus 1. That's why we have 2 to the power of n plus 2. And then for question B, we want to find T9. So what is T9? So we just need to replace the value of n here with 9. So what is our formula? 2 to the power of n plus 2, or you can use the general formula. Okay, so if you use the general formula, we have 8 multiplied with 2 to the power of 9 minus 1. So we get directly 2048, sorry. But we can also use the general formula we found in part A, which is 2 to the power of 9 plus 2. So what is 9 plus 2? 11. So what is 2 to the power of 11? So you will get the same answer, 2048. Second example. The nth term of sequence Tn is equal to 2 over 3 to the power of n minus 1. So, the question asks you to, the first one, show that it is a geometric progression. How can we show this is a geometric progression? Because we don't have the progression. We only have the nth term of the sequence. Okay, for part B, find the value of n, where n equal to 256 over 6561. Okay, so the first part of this question, we want to show the geometric progression by, yes, we have to show our common ratio exists for the progression. So what we can do, we know the ratio can be found by finding the division between the term and the term before that. So it can be T2 over T1 and then T3 over T2. If we have the same ratio, then it is a common ratio. But we can show also by using the general part of it, which is R is equal to Tn over Tn minus 1. So using the general form only, we can prove that every value is in this will be follow the geometric progression. So what is Tn? Tn is 2 over 3 n minus 1. And then for Tn minus 1, it will be 2 over 3 n minus 1 minus 1. So what will be? 2 over 3 to the power of. So this is the same base, so we can apply the rule of indices. So it will be n minus 1 minus, because it's divide, so minus n minus 1 will be n minus 2. So what we will get here will be 2 over 3 to the power of 1. So we have a common, the fixed value for ratio, which is 2 over 3. So it will be the same ratio for every term with its previous term. Okay, so generally you can do like this to find the R generally, not finding for every term in the sequence. Okay, how about question B? We want to find Tn. So what is n when the value is equal to 256 over 6561? Okay, so we just have to replace the Tn with the general expression there. So 2 over 3 to the power of n minus 1 is equal to 256 over 6561. So what we can do, because this is 2, this is 3, we can change this into base 2, and then this one also to base 3. Or if we cannot do that, we can apply log on both sides. So you can choose which one method you want to use. Okay, so for this method, what I will use is to change this into the base 2. So this is actually, we can just try and error by using your calculator. 2 multiplied by 2, 4. 2 multiplied by 2 again, and continue up to 256. So it's actually 2 to the power of 8. And then 6561, you can try, oh, that may be 3 to the power of 8 also. So you can just directly try by using your calculator, try and error. Okay, so from here we can directly compare that the power is n minus 1 equal to 8. So n minus 1 equal to 8, so n equal to 9. So this is the ninth term. Okay, so n equal to 9. Okay, the next part of geometric sequence, the same as the arithmetic sequence, which is we need to know what is the sum of the first n term in the geometric sequence. So this is the sequence. We need to know the sum. We can use directly the formula as n equal to a multiplied with 1 minus r to the power of n divided with 1 minus r if r less than 1. Or if r more than 1, we can use the opposite position of this value 1 and rn. It will be the same. You can use both, either one of these. So you can use one of these even though the value of r is more than 1. It will give the same answer. So don't worry about it. Okay, so you can remember both, or you can use only one of these. Special for geometric sequence, we will have a sum to infinity. So we don't know how to prove for this formula, we just have to use. If the question asks you to find the sum of infinity, we can use this formula as infinity equal to a over 1 minus r, where absolute r is less than 1. Means that the r is in between -1 and 1. So example for this part, find S5 of the geometric progression in which a equal to 27 and r equal to 2 over 3. So we have the value of a and r, we just need to substitute into the formula. So S5 is equal to, what is the formula? Yes, Sn equal to a to the power of a multiplied with 1 minus r to the power of n divided with 1 minus r. So just substitute the value of a equal to 27, r equal to 2 over 3, and n equal to 5. So by using calculator, don't forget to check your bracket and then the power. So it should be a bracket of 2 over 3, close bracket, and then to the power of 5. Okay, please make sure you have you calculate by using the same method, the correct method in calculator. So the answer will be 211 over 3. Directly you get the answer just by using the formula. Example 4. Calculate the sum to infinity of the series. So we want to find S infinity, which is the formula a over 1 minus r. So we need to know what is a, what is r. We don't have to know what is n. Okay, so what is our a? So 2 is our a. What is our r? So we just have to divide 1 over 2 with 2, which is 1 over 4. Okay, so we have a equal to 2, r equal to 1 over 2 divided by 2, which is 1 over 4. So S infinity equal to 2 divided with 1 minus 1 over 4, which is the answer equal to 8 over 3. Okay? Okay. Next example. Express each of these number as a quotient a over b. What is this question? So it's actually by using the progression, we can express this value into a fraction. So it's actually related to our rational inequality. Sorry, rational number in the set. To solve these questions, for question A, 1 over 6 bar. So means that this number will be 1 over 6, 6, 6, 6, 6, and so on till infinity. So what we should do? We know that this is actually 1 plus 0.6 and then 0.06 and then add up 0.006 and continue to infinity. And then this part will be a progression. Okay? So, what is the first term of this? This is the first term, a equal to 0.6, and then what is the common ratio? So, you just have to divide 0.06 with 0.6. You will get, yes, 1 over 100. And then for this one, we can try check 0.006 divided with 0.06. So it's actually, sorry, 1 over 100, but 1 over 10. Okay, if you're not confident, you can continue to check lah. Okay, so we have AR, so we can find the S infinity because this value will continue to infinity. So what is S infinity? A over 1 minus R, so was 0.6 over 1 minus 1 over 10. This is for the 1 in bracket, the point part. So we just add up 1 to get the 1.6 bar. So what is the answer? It will give you in a fraction form, which is 5 over 3. Can you just calculate using your calculator? Do you get the 5 over 3 equal to 1.666666? Yes. You will get 1.66666666 in your calculator. Let's do for question B. So 5.459 bar. 59, repeating the 59. So we just have to separate the one with repeating with bar with the number that don't have the bar. So we separate 5.4 with 0.059, 0.00059, and so on. So we repeat the same step with the question A, and then we will have the A, the first term equal to 0.059, the R, the ratio between the second and first term will be 1 over 100. And then what we should do? We just have to find the sum to infinity because it won't stop up to infinity lah. And then just substitute into the formula of S infinity, and then 5.459 bar will be equal to 5.4 plus with the S infinity of the everything inside the bar in the sequence. So it will give you the answer in fraction, which is 1081 over 198. So you can check using your calculator. You will get the same value, 5.45959595959. Okay, so this is for the first part. Please stay back for the second part, which is the binomial expansion.